Have you ever wondered what your favorite gummy candy, the smooth jelly layer in desserts, or even the capsules of the medicine you take every day are made of? The secret lies in gelatin, a familiar ingredient with a surprisingly fascinating production process that not many people know about. In this video, we'll take a deep dive into how gelatin is made in factories, from its raw materials to becoming a key ingredient in countless everyday products. From food and pharmaceuticals to cosmetics, gelatin is everywhere, often without you even realizing it. Join us as we explore the world of gelatin production and discover why it's such an essential part of our lives. Gelatin comes from collagen, a protein abundant in animal skin, bones, and cartilage. Since ancient times, people have harnessed this ingredient by boiling animal bones and skin to create a thick, adhesive broth used for cooking and medicinal purposes. It wasn't until the 19th century that gelatin began to be produced on an industrial scale. A major breakthrough came from British scientist Peter Cooper, who patented the gelatin production process in 1845. His invention not only extended the shelf life of food before refrigeration technology emerged, but also helped preserve perishable ingredients. During World War I and World War II, gelatin became an essential resource for the military. Its long shelf life and easy transportability made it a reliable food supply for soldiers, ensuring they had nutritious meals even in prolonged wartime conditions. Today, gelatin is an indispensable ingredient in the food industry. From gummy candies and desserts to processed meat products, it plays a crucial role in gelling, stabilizing textures, and enhancing food quality. Beyond food, gelatin is widely used in pharmaceuticals and cosmetics, proving its lasting value in modern life. The gelatin production process begins at meat processing plants, where collagen-rich raw materials are carefully selected. The primary sources are pigs and cattle, including bones, skin, and connective tissues, parts that contain high levels of collagen and are essential for producing high-quality gelatin. At these facilities, workers separate lean meat for other products while collecting bones, skin, and connective tissues specifically for gelatin production. Large bones are cut into smaller pieces using specialized machinery to improve processing efficiency. The raw materials then go through a thorough cleaning process to remove excess fat, ensuring the highest possible purity for the final gelatin product. This meticulous preparation not only enhances product quality, but also optimizes collagen extraction in the subsequent processing stages. Each week, the factory processes around 20 tons of raw materials, including skin and bones, for gelatin production. When shipments arrive, workers conduct a thorough quality inspection to ensure the materials meet strict standards before entering the processing line. The skin is then sorted and placed into designated storage containers. The skin undergoes an extensive washing process to remove impurities, ensuring the highest purity for the final gelatin product. Meanwhile, tough bones are fed into high-powered grinding machines, where they are crushed into small fragments. This step not only improves collagen extraction efficiency, but also prepares the materials for the next stages of processing. Once cleaned, the skin undergoes an alkalization process. It is soaked in large vats of lime solution for 7 days, breaking down collagen structures and softening the material. Next, the softened skin moves to the acid treatment stage, where it is immersed in a diluted acid solution for about 10 hours. This step enhances gelatin extraction efficiency, reducing the overall processing time. After soaking, the materials go through an intensive washing and neutralization process to eliminate any residual chemicals, ensuring a pure and safe final product. To produce high-purity gelatin, the factory is equipped with stainless steel tanks connected by a complex network of pipelines. This sterile environment prevents contamination and allows for precise control over key factors such as temperature, pH levels, and concentration, ensuring maximum efficiency in the production process. After undergoing initial processing, the raw materials are heated in water at approximately 160 degrees Fahrenheit. This process extracts gelatin from collagen by dissolving protein fibers and breaking down the molecular bonds that hold them together. The resulting solution is rich in protein, forming the foundation for the final gelatin product. Depending on the desired purity, This extraction process may be repeated multiple times to yield different grades of gelatin. Precise temperature control is crucial. If the temperature is too high, the collagen structure can break down, reducing the quality of the gelatin. On the other hand, if the temperature is too low, the extraction process slows down, affecting production efficiency. To optimize the gelatin extraction process, factories use an acidic environment to enhance collagen solubility. The most commonly used acid is acetic acid, better known as vinegar. This acid helps break down protein bonds, making collagen easier to dissolve into the solution, thereby increasing gelatin extraction efficiency. This step is crucial for ensuring high-quality gelatin and improving overall production effectiveness. As the collagen dissolves, it forms a thick, viscous solution, similar to concentrated broth, rich in soluble proteins and organic compounds. However, at this stage, the solution is still cloudy and contains various impurities, including undissolved solid particles. To achieve the desired clarity and purity, the gelatin undergoes a thorough filtration process. This critical step removes any remaining impurities, ensuring a high-quality final product. To ensure the highest level of purity in the final gelatin product, the collagen solution undergoes an extremely rigorous high-pressure filtration process. The factory utilizes an advanced filtration system with ultra-fine ceramic membranes, capable of removing even the tiniest impurities that are invisible to the naked eye. Under immense pressure, the collagen solution is forced through micro-perforated filters, effectively separating out insoluble particles, excess proteins, and unwanted organic compounds. These highly precise filters are arranged within an extensive pipeline system stretching up to 3 miles, incorporating multiple filtration stages. This multi-layered setup ensures maximum efficiency, completely removing impurities while preserving the integrity of the collagen structure. Pressure and filtration speed control are critical in this process. If the pressure is too low, impurities may not be thoroughly eliminated, while excessive pressure could damage the collagen molecules, compromising the quality of the gelatin. To prevent this, the system is carefully designed to maintain optimal pressure, allowing only the purest collagen to pass through while retaining its essential properties. The result of this meticulous process is a crystal-clear collagen solution, entirely free of impurities, ready for the next stage of gelatin production. Although the collagen solution has undergone thorough filtration, it still contains small amounts of dissolved salts and excess water. To remove these, the solution is passed through tanks filled with ultrafine synthetic resin beads that absorb the remaining salts. Simultaneously, high temperatures in the tanks help evaporate excess water, concentrating the collagen solution to an optimal level. After this process, the solution thickens to a consistency similar to honey. This stage, known as concentration, significantly reduces the volume, where approximately 2 quarts of collagen solution yield only about 7 ounces of pure gelatin. The gelatin is then slowly cooled, transitioning into a semi-solid state with its characteristic elasticity. Next, the gelatin is extruded through a perforated plate, forming long strands similar to noodles. These strands fall onto a conveyor belt and are dried using a sterile stream of hot air, which removes all remaining moisture while preserving the gelatin's quality. Once fully dried, the gelatin is finely ground into a powder, ready to be incorporated into food, pharmaceuticals, and various other applications. Finally, the powdered gelatin is carefully packaged into large bags or sacks, each capable of holding up to 1 ton of gelatin. From there, it is ready to be shipped to food, pharmaceutical, and cosmetic manufacturers worldwide, where it becomes a key ingredient in countless everyday products. Gelatin tends to clump when it comes into contact with water, making it difficult to dissolve. To prevent this, manufacturers often mix it with other powdered ingredients such as sugar, while stirring rapidly and continuously. This process ensures that the gelatin absorbs water evenly without forming lumps. The mixing system uses a high-speed rotor to create strong suction, pulling the powder from the liquid surface and quickly wetting it. The entire solution passes through the mixing head multiple times within a short stirring cycle, ensuring a perfectly smooth mixture free of clumps. Beyond gelatin, this mixer is also used for dissolving sugar and other raw materials, helping maintain a uniform texture in the final product. Depending on production needs, flavorings or additives may be incorporated to create different gelatin formulations tailored for specific applications. Thanks to its unique gelling properties, gelatin plays an essential role in various industries. In the food sector, it is widely used in candies, desserts, dairy products, and processed meats. Additionally, gelatin serves as a stabilizer, thickener, and gelling agent in the pharmaceutical industry, where it is used to produce capsules and tablets. It is also found in cosmetics, adhesives, industrial films, and protective coatings. With its versatility and wide-ranging applications, gelatin remains one of the most indispensable ingredients in modern life. The global gelatin industry is now valued at an impressive $4 billion, playing a crucial role across various sectors, especially in gummy candy production. Iconic brands like Haribo and Jell-O have been around for over a century, predating even major F&B giants like McDonald's, Starbucks, and KFC. Though gelatin makes up only 5 to 10% of the total candy weight, it is the key ingredient that determines whether a batch is a success or a failure. Gelatin is what gives gummy candies their signature chewy and elastic texture. However, the production process doesn't always go smoothly. There are several potential risks with gelatin that can turn an entire batch of candy into waste. One of the most common issues is inconsistency in firmness and viscosity, preventing the candy from achieving the ideal chewiness. If the wrong grade of gelatin is used, or if the formulation is incorrect, the final product may turn out too soft or even start melting before it reaches consumers.